Okay, so today we're going to continue talking about how to rotate figures on the coordinate plane. So you should have watched a few videos yesterday of other teachers actually explaining how you can create these different rotations. So how to create 90 degrees clockwise, 180 degrees clockwise, and 270 degree clockwise rotations. So today we're going to look at how you actually do that, and hopefully you kind of have a little background on it after watching those videos. Okay, so it says rotate the figure shown at the right 90 degrees, then 180 degrees, and then 270 degrees clockwise. After each rotation, record the coordinates of the image in the appropriate table. And it says look for any patterns and try to create an algebraic representation for each rotation. So what I want you to do at home right now is get a piece of, it doesn't matter if it's notebook paper or plain paper, and I want you to trace over this triangle here. I want you to trace it so it's exactly the same on your piece of paper. So go ahead and pause the video and do that. Okay, so once you've done that, put the piece of paper exactly where it is so that it lays right on top of your triangle. And I want you to put a pencil so that it's right in the middle on the origin. Okay, put your pencil tip there. And I want you to turn the paper 90 degrees. So that means turn it so that your triangle ends up about right here. And this is I didn't draw the exact triangle, but I want you to just keep your pencil where it is and just turn the piece of paper on top. Okay, so I went ahead and I drew my triangle after I rotated it 90 degrees. So now I want to look at the relationship between the original points and my points when I rotated it 90 degrees. So in the original image, okay, should be in yellow. Excuse me, I'll do that with highlighter. Here's where A is, okay? Now I want to look at what point is A at in my new image. So if I'm going to write that, that is at 1, -2, okay? Now I'm going to just do that for the next 2 points. Okay, so as you can see, I wrote down the where the new B and C points are. So I want you to pause the video, look at these points, and tell me what do you notice. Okay, so in my own words, I noticed that X and Y values switched. Okay, something else I noticed is that X became the opposite sign. Now the same thing with reflections applies to rotations. So that negative sign that we're going to use here in our algebraic expression or representation means the opposite of. Okay, it doesn't mean negative, it means the opposite of. So if it is positive, it makes it negative, but that's because the opposite of a positive number is a negative. Now the opposite of a negative number is a positive, so that's where it gets tricky and why you have to remember that it means opposite, not negative. So algebraically, we're switching X and Y, so Y is going to come first now. We're taking the opposite of X. Okay, so we're flipping X and Y, and we're taking the opposite of X. So anytime you are rotating 90 degrees clockwise or 270 degrees counterclockwise, right? Because from here to here is 90 degrees. Okay, that's 90 degrees clockwise. Okay, but also if we went from here all the way over here, we would get the same thing, and that's 270 degrees counterclockwise. So no matter if we rotate it 90 degrees clockwise or 270 degrees counterclockwise, you end up in the same position, so you can use the same algebraic representation, okay? So I'm going to highlight that in pink, okay? Then I'm going to erase this stuff here, and I'm going to highlight my triangle in pink, okay? So the algebraic representation for that one is the one in pink, okay? Okay, so now we're just going to do the same thing for 180 degrees, okay? So I want you to take that same piece of paper, but in a different place. I'm sorry, not in a different place. Put it back on top of your triangle, and this time I want you to rotate it 180 degrees clockwise, okay? Or counterclockwise. You'll end up in the same position no matter which way you go. So go ahead and pause your video and do that. Okay, so I went ahead and I rotated my pre-image 180 degrees. That puts me in quadrant 3. And I went ahead and highlighted this one in my blue. Okay, so 180 degrees clockwise and 180 degrees counterclockwise. Those put me in the same position, okay? And in this case, that's quadrant 3, okay? So I went ahead and I wrote where the new points are at, okay? So what are you guys noticing now with my points? What's happening between the X and Y coordinates in my pre-image to my image here? Okay, so what happens as I go from here to here? Okay, so hopefully you saw that we took the opposite of X and then we took the opposite of Y. Okay, they became their opposites. Okay, if they were positive, they became negative. Now, we represent that with a negative sign, but that means opposite. So opposite X, opposite Y. In my own words, I would say X and Y became opposites. So now these are just rules that you kind of just have to know them. You have to be able to use them. For any tests or quizzes, though, I personally would provide you with these rules. And I don't know that, unfortunately, I don't think that I will be still your teacher till at the end of this unit. Mrs. Fraser will be back, I think, around the 16th or 17th of April. And we have Easter break coming up, so I won't be reaching the end of this unit with you, and I'm not sure what she will do with you, but I will provide you, and I think I may have already provided with you a cheat sheet to kind of use during any assignments that we have here, but I always let you use your notes anyway, okay? So yeah, so I'm going to highlight that. That's what's happening when we do 180 degrees clockwise or counterclockwise. We take the opposite of both X and Y. We're not flopping them at all this time. We're keeping them in the same place. We're just taking the opposite. Okay, so last, I want you to take that same piece of paper, lay it on top of that triangle, and I want you to rotate it a whole 270 degrees clockwise or 90 degrees counterclockwise. Whichever way you go, you should end up in the same place. Okay, so I went ahead and I rotated mine 270 degrees clockwise, which is also 90 degrees counterclockwise, and I highlighted that in green. Okay, so this time I'm going to write down where my points are with you guys, so that, I like it that big. So at -1, +2 is where my new A is. My new B, I guess you could probably figure this out just by looking at where A was, but that's going to be -1, +6. And C was at -7, +4. So, in our own words, what's happening? Well, we switched X and Y again, so X and Y switch. Okay. And then this time, the Y values become opposite. Okay, so this time our Y values became opposite. So to represent that, we have to switch X and Y. So it's y, x, but this time my y values are my opposite. Okay, so this time we have opposite y values after we flip them. Okay, so for 270 degrees clockwise, so that means the whole way around, okay, or, so that's 270 degrees clockwise, or just 90 degrees counterclockwise, which would be one way to the left, we take the opposite of y, and then we flop x and y, okay? We flip them, sorry. Okay, so these three charts right here that tell you that algebraically how to do it are very, very important to you. So I do always share the notes with you. I always share them. So I do recommend that you kind of study this, get to know it, remember them, okay? So let's look at down below here. Number 8, it says, the coordinates below represent rotations. Use what we learned to describe what type of rotation occurred. So my original point at x was at 9, 8. Now it's saying x prime is at 8, negative 9. So it looks like we flipped x and y, and then we took the opposite of the x value. So which one represents that? Pause your video and figure it out. Okay, so hopefully you said that it's 90 degrees clockwise, or remember 90 degrees clockwise is the same as 270 degrees counterclockwise. Okay, so those are the same things. And we figure that out because here's x, y. Okay, that's the original x and y point. What did we do here? Well, we put y first, right? Because y was 8. And then we took the opposite of our x value, which was negative 9. Okay, so I want you to pause the video and I want you to try 9 and 10 on your own. Then come back once you figure it out. Okay, so we are back and there are the answers to 9 and 10. Excuse me. So if any of you are having trouble with kind of visualizing when you have points, you're welcome to always sketch a graph, okay? And you should know this from a different math class that you've taken in the past. I don't know, maybe 5th, 6th grade, where you talk about the quadrants. And in this quadrant, x and y are both positive. In this quadrant, x is negative, y is positive. In this quadrant, x is negative and y is negative. And in this quadrant, x is positive and y is negative. So when we're looking at any of these, it's saying, so number 8, for instance, x and y are both positive. So you know it's in this quadrant, okay? Whenever it gets rotated, it ends up in, well, x is now positive and y is now negative. So it ends up in this quadrant, okay? So if it ended up in this quadrant, there's only 2 things that could have happened. It either went this way, okay, so that's moving 1, 2, 3 quadrants, so that's 270 degrees, and that would be counterclockwise, or it's moving this way to be right there, so that's 1 quadrant, and that's clockwise, so that's 90 degrees clockwise, okay? So if you're having trouble with just looking at your points and determining how it's being rotated just by looking at points, you can always draw this little graph here and write your positives and negatives and then put stars where they end up and then draw your arrows. If that helps you, that's fine. Whatever's going to help you out here, I want you to try to do, okay? All right, so last 2 questions. Number 11, do rotations preserve or change the orientation of a figure? What does orientation mean? It means the position, right? The place, where is it at, okay? So let's look up here. Originally, it's straight up and down like this, okay? Is it ever straight up and down again when we rotate? No, okay? So the orientation is actually being changed in a rotation, okay? Do rotations preserve or change the size of a figure? Well, let's look at the size. Does the size of this figure ever change? It doesn't, so it preserves. And does anyone remember what type of transformation preserves the size of a figure? And we only touched on this on the first day when we talked about basics. That's actually called a rigid transformation, and this is the last rigid transformation that we will be talking about. Okay? So, preserves and its rigid transformation. Okay, so that is all for rotations.